Hello everyone, and good evening, and welcome to this episode number 5 of our fortnightly online series, the discussion series, where we discuss ideas, problems, and uh, queries. So, welcome all of you once again, and thank you all those who are joining today on a weekend. And also welcome to those who would be watching this stream sometime later. So here we are again back with our episode number 5. So as you know, this is a multi-segmented episode, and we try to take up problems, and we discuss some projects and then share ideas. So then let us begin. I hope the voice and everything is all right, and you can see the screen as well. Good. So we begin then with our first segment, and that is where we discuss some problems and their solutions, of course. So this time, we are taking a problem that actually someone asked us just yesterday. So till yesterday, I was also thinking what problem to add this time, and the form that we circulate usually. On that form, I got this very interesting problem that was shared, and that is the problem that we are going to take today. So this this episode, we are going to actually understand or look into the access system that is used in the softwares and their interpretation, that how each analysis quantity has to be understood. So this is a problem that most of us, I have seen people facing, and not only young engineers but also practicing experienced structural engineers face this problem, that they are not able to understand what is M22, what is M11, what is V13, what is V23, how to understand the axis of bending, how to understand the direction of bending. So all these issues are quite often faced by many of us. So we just thought that this was a good problem to discuss this time. So I must say over here that in our courses, we always try to devote at least 1 or 2 sessions in just understanding the proper directions of these forces analysis results, and how they will act, how to interpret their vector quantities. So we actually we spend quite a lot of time discussing these issues, because we understand that this is quite often faced by most of us. So this was a good problem to discuss this time. How many of you face this issue or have faced such issues in the past, where they do not understand how to interpret the direction of bending, or how to understand that for a particular, let us say, shear force, where to provide stirrups? Has any one of you faced such issues? Most of us face. So that's why we thought we will take this up. So the analysis results are vector quantities, which means that their direction of action is very important to understand, isn't it? For example, I just gave you, uh, for example, I just gave you this. I just gave this example that, let us say, if there is M11 bending, then how to understand M11 means bending in which direction, how to put reinforcement in which direction. These issues are important for us to interpret properly. So that's what we are going to look into in more detail. So every software, any software that you use, whether you are using etabs or statpro or safe or sap 2000, they generally use a dual axis system. So there will be a global axis system and there will be a local axis system. So mostly, uh, the case is that the nodal analysis results are shown using the global axis system. All right, and the member results and uh, yeah, element results, I should say, not only member. Any element results are usually shown using the local axis system. So global axis is mostly for displaying the nodal analysis results or deflections, and element results are represented using the local axis system. So what is the axis system then, which is followed by the software? So if you see, this is the screen where I'm showing ETABS axis system to you. So you can see this three arrows on your left side. That is the global axis system, XYZ. X in red color, Y in green, and Z in blue. And then on your right side, you will see the axis system for members. So the first image, top left image, is for a beam. So now you can just try to correlate that the red arrow will be your local axis 1 1. Why 1 1? Because if you see over here, the local axis 1 is represented by the red color, local axis 2 is represented by the green color, and local axis 3 is represented by the blue color, RGB. That is how you can try to remember it. So if you can see a beam along the length, which is the axis that you see, which local axis? So along the length you see it's the local axis 1, isn't it? Then in the cross sectional directions you will have the axis 2 and 3, local axis 2 and 3. Similarly for the column, if you see along the length of column, you see local axis 1. Along the cross sectional dimensions you will get local axis 2 and 3. For shell, you will see that the in plane axis is local axis 1 and 2, and out of the plane axis is local axis 3, and same is the case for walls. So the bottom right image is that of the walls. So this is the local axis system that these are the axis system that ETABS follows. You have got a global axis by the name of XYZ, and you have got the local axis by the name of 1 2 3. Then over here I am showing you the axis system which is adopted in StatPro. So I think most of you know that the axis system StatPro adopts is slightly different. So the global axis, top left corner, you will see planar axis are X and Z, out of plane axis is Y, and then you can see the axis systems used for members. So for beam, you will see, for column, you can see for yourself. Bottom two images are of slab and a wall. So here the notation that STAD uses is small alphabets for local axis. Okay, so the blue color is representing local axis X, and the local axis is written in small alphabet, small x. The red color is representing local axis Y, and green color is representing local axis Z. So they are following a BRG pattern, you could say. ETABS was following a RGB pattern. Uh, STAD is following a BRG, local axis XYZ. So far so good. These are the axis systems being followed. Now, wherever you want to see any member result, then the forces are always represented along the local axis. Very important for us to remember this thing, that the forces will always be represented along the axis, local axis. Moments are represented using the about the axis configuration or orientation. So that would mean that to understand the direction of movement, you need to use the right hand thumb rule. And displacements are represented along the global axis. So this is for your element results. Sorry, for member. When I write member, that means beam, column, line elements. For shell elements, forces are once again represented using the local axis, but movements this time are represented using the local axis, and that is along the local axis, not about. In frames, it was about the local axis, but in shells, movements are represented along the local axis, not about. So that is a major and important distinction that you need to understand. And displacements once again are represented along the global axis. So now I have tried to make some quick pictures and you can see it for yourself. So I have taken the example of ETABS for forces and generally forces, shear forces, axial forces, and how to look for their results. So as I told you, for member, the forces are along the local axis. So you can see I have written 1, 2, 3 local axis numbers. And now you can see for a typical beam, I'm showing this beam in 3D isometric view. This is how your forces and shears will look like. Okay. So F11 along 1, V22 is along 2, and it's a shear, and V33 is also a shear along 3. Then this is for bending, very important because most of us face difficulties in this. So this is for a member. On your left side, you see a 3D isometric view, and this will be called as M22 bending. All right. Or typically we would call this type of bending as a minor axis bending, bending about the minor axis of the beam. On the right side image, you see a plan view of the same. So on the right side, you can see it's the in plan bending that is happening, M22 bending. I hope you are able to imagine this. Any confusion till now? I think this is quite clear, isn't it? So this is the minor axis bending. Then this is how your major axis bending would look like. And we will call it as the M33 bending in ETABS. So we will be using the right hand thumb rule as I told you for bending. And the left image is the 3D isometric image. On your right is a front elevation of the same beam. So you can very clearly see that it is the major axis bending represented by M33. So in most of the cases, your beams will be having M33 as the critical bending as compared to the M22 bending. In fact, most of the softwares, if you are doing RCC design, that is, they do not design for the minor axis bending. I'm talking about the RCC design. Most of the softwares are unable to design for minor axis bending in case of beams, RCC beams. Good. Then this is column. Once again, the basic concept of forces along the local axis will be applicable. You can see the forces and the shears. Now bending in column, very important. So on your left side, you see 3D isometric view, M22 bending, minor axis bending in the column. On your right side, you see a side view of the same column. Okay, M22 bending, bending about the minor axis. I hope these directions are making uh, things clear to you. Then this will be a major axis bending, bending about the major axis. Again, on your left side, you see a 3D isometric. On your right side, you are seeing actually a front elevation. So this is how your M33 bending will look like. All right. So as I told you, member results will be uh, for moments. You will be using uh, about the local axis configuration or understanding, and for forces and shears, you will be using along the local axis direction. Now we come quickly to the shell results. So once again, forces and shear in shell results will be along. So this is how your local axis, oh sorry, this is how your forces and shears will look like. So I have represented F11 direction force, F22, V13 and V23. This is for shells. So what did I tell you about the movement? For movement in shells, they are displayed or they are represented using which sense? So they are actually shown using the along sense, not about. So now you see a shell on your left side, and this will be this bending. If you see, it is happening along the local axis 1, isn't it? So for shell, we will call it as the M11 bending. I hope this is making sense. Okay, so this is the along bending in shells, therefore this will be M11 bending. On your right side image, you see the same uh, shell from a front view orientation. I hope you are able to understand how this M11 bending will look like. So if you have to put reinforcement, an easier way to understand is if you have to put reinforcement for this M11, in which direction will you put the reinforcement? Let us say you have to put a reinforcement for this uh, M11 bending moment. In which direction will you put the reinforcement, along 1 or along 2? So you will be putting your reinforcement along the local axis 1. Okay, very important. This is how your M22 bending will look like. Just to compare, this was M11. I went a slide back, and again M22. So why we are calling this as M22? Because the bending is happening along 22, along the local axis 2. And if at all you want to put reinforcement, you will be putting it along 2. Very interesting. What is this? Uh, what is this happening? So this is called as a in plane bending. All right. This is the in plane bending of your shell element. So do we get to see this type of a behavior? And if at all, in which type of action do we get to see this kind of a behavior? In plane bending of a slab. Anyone would like to comment on this? Under which condition or in which situation do you get to see the in plane bending of your slab? These are the images which I have shown for in plane bending. So you get to see these in plane bendings typically when your slab has a diaphragm like action. I think most of us understand diaphragm like behavior. So generally the lateral loads are transferred because of the diaphragm action of your slab. So any slab panel, when it is rigid, it has a very, very high in plane bending resistance, isn't it? Uh, any slab panel which what did I say? Which is rigid has a very, very high in plane bending resistance. Why it has a very high in plane bending resistance? Because it has such a large depth. If you see, I think you can imagine for in plane bending what will be the width and what will be the depth of this cross section if you wanted to find out the moment resistance, isn't it? So it has a very, very high in plane bending resistance in rigid diaphragms. General RCC slabs 150 thick with proper reinforcement without openings, it behaves as a good rigid diaphragm. But in flexible diaphragms, there is a problem, isn't it? So this in-plane bending, you do not get good resistance in in-plane bending. So then we have to do all sorts of jugglery. We have to provide collector elements. We have to design uh, beam elements to carry a lot of axial loads due to the diaphragm action and all those things. Anyway, I just thought I would include this image so that we can understand the in-plane bending behavior of your shells. Now, this is the how to interpret wall results in ETABS. When I say wall means any retaining wall, or you are using a wall for tank design. Uh, in that case, these are the local axis that you have to, sorry, that you can see on your screen, and the local axis system is same as that for any slab element or shell element. So you see 1 1, 2 2, and 3 3. 3 3 is out of plane, 1 and 2 are in plane. Okay, then so these are wall results. Now very interestingly, when you assign pier level to any wall, I'm talking more with respect to ETABS. So when you assign pier level to any wall, then the local axis system, can someone tell me this local axis system of a pier, it represents which element? This local axis system, if you see, one is along the length of pier wall or shear wall, I would say, RCC structural wall. Two is also in plane, three is out of plane. So this represents these local axis system of a pier. This represents the local axis of a column. All right. So this is very important for us to understand. If you see, this was the local axis of a wall, general wall. If you are creating in ETABS, this is the local axis system. But when you assign a pier level to it, the local axis system of a pier changes. And when you get design of your shear wall, RCC structural wall, then the analysis forces are, just a minute. Yeah. So the analysis forces you get in these terms. Very important. All right. So this is what happens in ETABS. I hope you have understood. So in StatPro also same understanding. The only change will be that StatPro will be using small alphabets X, Y, Z for local access. All right. Otherwise, the overall interpretation of directions remains the same. So this is what I had to tell you regarding this issue of understanding the directions of vector quantities. So I hope some of the doubts were cleared through this discussion. All right. Now we, before we invite our guest, we have one more segment to take, and this is where we take up one project and we try to discuss it. So this time we did not get any interesting query, any interesting project related query. So I thought I would share some interesting, what to say, some interesting, uh, what will I say, interesting project from one of our past projects. And why it is interesting? Because I would be talking on a less discussed topic through this, and that is what we can call it as the value engineering. Okay. So what do I mean when I say value engineering? So as a structural designer, we have a lot of responsibility uh, to build sustainable and cost optimum designs, isn't it? So it's not our duty not only to produce drawings to do designs, but our designs should be optimum. They should be saving money for your client. That is very important role of a structural designer. So just to give you an example, when we write, let's say, 8 dia stirrup at 150, so what you are writing uh, on a piece of paper using a pen, that gets executed on site, isn't it? That will be what will be provided on site. So you should understand and you should actually think that what you are providing, is it required, is it optimum, whether you can economize any further. That is one very important question you should always ask yourself. So that is a very big responsibility that we as structural engineers have. So uh, in the same light, I would just like to take up this project that we did, and I would demonstrate that how using good engineering judgment and how by using good common sense we were able to save crores of rupees for our client. So the title is value engineering that we have given. Very interesting. So just be involved in this discussion. So we were actually given the work for a campus infrastructure construction project. It was the phase 2 of the campus infrastructure development. Phase 1 had already happened, and it was an institute of national importance. So for that institute, we were assigned, or we were tasked as a structural consultant. And what was our role? To provide the campus infrastructure phase 2. As I said, phase 1 had already happened, and we were actually provided all the information that was uh, all the design outputs, all the drawings, details, everything that was done in phase 1 we were given, because we were going to do the phase 2. So we were told that the work is quite simple. You just need to use the drawings of phase 1. Everything is done, everything is sorted, all the designs are checked, found okay, and you, it's quite an easy task for you. Just provide the same detail, just like copy paste, just give the same designs for phase 2 as well. So but that did not sound very well, very good to us, and we decided to dig deep, and we decided to come up with a optimum design as per sound engineering calculations and as per good sense. Having a good sense is very important when it comes to structural design. So here I'll be taking a case where we provided a crust design. I hope you understand crust design. Crust design means in roads, when we are doing pavement designs, you have different crusts, isn't it? You have a pavement quality concrete, then you will have a dry lean concrete layer, you will have a GSB layer, you will have a subgrade layer, you will have a drainage layer. So that is called as the crust design. So to find out the thicknesses of all these crusts is actually called what we call as the crust design. Okay. So what we were told that the crust design cross sectional drawings are already ready for phase one, already executed work. You just use the same drawings, just paste the details in your drawings and just give it to us. We will execute. All right. Let us see what we did. So this was the sorry, this was the crust cross section that was provided in the phase one. I think you cannot read it because the drawing was quite big, so I could not fit it in one cross section. Sorry, one slide. So I'll just go to the next slide to show you the crust details. So on your right side, you can see the crust details. So we this is as per phase one. Okay, we did not do this. This was a different consultancy firm that provided this design. So they had provided 300 pavement quality concrete, M40 grade, that is quite substantial grade. 150 DLC. DLC means dry lean concrete. 100 GSB, granular sub base, and a 500 subgrade. So this is the strata that they provided, where you have a 600 to 800 black cotton soil. Okay, that region had some black cotton soil layer also. The layer was varying from 600 to as high as 3 or 4 meters. So assuming you have a good strata, absence of black cotton, absent when I write absence of black cotton, that means not uh, BC soil not beyond 600 to 800 All right. So this is the strata that they had come up with. So yeah, 300 PQC, M40, 150 DLC, 100 GSB, 500 subgrade. Assuming the road level to be 150 above the NGL that we try to maintain, the subgrade was 900 below the natural ground level. So that means you had to do excavation of 900 Okay. Interesting to note over here is that, let us say, even if you have only 600 black cotton soil, and let's say you have underlying hard strata below it, still you will have to dig in 300 hard strata. I hope you are getting this. You are getting the point. So excavation of 900 was required every time you are going to provide this cross section. Okay. So when we looked at it, we did not find this very optimum looking design. And actually, if you see this type of a cross section that they have proposed, this is type of a cross section that you get in national highways. Okay, this is quite substantial. 300 PQC M40 is quite substantial. So this type of cross sections you get in very heavy traffic load. So when we were tasked with this project, KCPL means our structural consultancy firm. So when we were tasked with this project, we actually took these decisions. So first of all, I told you that this project was inside a campus, an institute, residential campus it had. So you do not expect very heavy commercial vehicles, isn't it? What is commercial vehicles? So the code tells us that any weight which is more than 3 tons laden weight, that is called as commercial vehicle. So you do not expect lot of traffic of commercial vehicles on that road, isn't it? Because it is, remember, it is the road inside the campus. So the road was inside the campus, so we did not expect vehicles more than 50 commercial vehicles per day. So the IRC 58, which we use, that is the code for rigid pavement design, that actually deals with vehicles which are 450 CVPD on your road, 450 commercial vehicles per day. So therefore, this code, this IRC, we thought is not quite applicable in our case, and so we went to IRC SP62. All right, what is IRC SP62? It is a special publication of IRC for low volume roads. Just give me a minute. Yeah, so it is a special publication of IRC for low volume roads. So for traffic loads less than 50 CVPD, actually the code gives you quite a leeway, and it allows you to design only for the edge stresses. So there are different positions of wheel loads. There are different conditions of temperature variation. So when you if you are if you know or if you are aware of pavement design, rigid pavement design, then there are different conditions that we have to take into account. One of the condition is wheel load at the edge plus temperature variation, wheel load at the corner plus temperature variation. Those kinds of conditions you have to take into consideration. So here your IRC SP62 quite clearly says that because this is a low volume road, you need to take either you take the wheel load and you ignore the temperature difference. Okay, you don't have to take both the conditions because it is a low volume road. So you don't take both the maximas, you just take and just design for the wheel load. That's it. And that you use for thickness estimation. I have highlighted that clause from the code. So that's what we did. We did the design for the wheel load and not for simultaneous condition of wheel load and the highest temperature differential. The stresses only at the edges were taken, not at the corner, because again your code gives you certain guideline for it. And that's how we worked out the depths. So the depth was worked out using IRC SP62. It's freely available on the internet. You can also download and have a look at it. So we came up with, and all these designs were safe. We came up with 20 centimeter or 200 M25. What was the original thickness that was provided in the earlier design in phase 1? So if you remember, it was 300 M40. So we came up with only 200 M25. All right. We provided a 100 DLC and 150 GSB in accordance with, once again, IRC SP62 and IRC 15. Here we took a very here we took a decision based on good common sense that the subgrade, we did not give a 500 subgrade as was given in the phase 1 designed by the other consultants. So we said that the subgrade can be kept variable, isn't it? As per the black cotton soil encountered, we will keep the subgrade as variable, and we will not provide a subgrade where hard strata is encountered. See, there is no point providing a subgrade which is not that tough by removing hard strata. It does not make sense to remove a very hard strata by blasting or doing excavations and replacing it with a weak subgrade. It just does not make any sense. So we decided that subgrade will be completely eliminated if hard strata is encountered. And we also provided some nominal reinforcement. Most of our payments are provided without reinforcements, isn't it? But there are IRC publications which provide guidelines to provide reinforcement also if you want to do in a pavement. Those are called as continuously reinforced concrete pavements, CRCP. So we also provided some nominal reinforcement. So this is how our strata looked, our cross section looked like. If you can see, 200 pavement quality concrete, M25, 100 DLC, 150 GSB, and a varying subgrade on the basis of the black cotton soil that we will encounter. So, do you get it? So, this is what we did and how this ensured savings. So, let us look at that. So, what I have done to make things more interesting, that I am just presenting a comparative BOQ of 1 kilometer road, 7 meter wide pavement. The DLC is 7.2 meters, dry lean concrete layer is 7.2, and the GSB and subgrade are 7.4 meters wide. Okay, so in both the options, the design that was earlier used in phase 1 and the design that we presented, both have been compared. We have assumed an underlying 600 black cotton soil. Remember what we did? We decided that we will not touch the hard strata. As soon as we encounter hard strata, we'll stop. We'll not replace it by a weaker subgrade. In the earlier design, they were doing a 900 subgrade. Okay, the rates we have taken as per the prevalent CPWD schedule of rates during that period. That is the 2016 DSR. So I have just pasted an image of a 1 kilometer wide stretch, 1 kilometer long stretch of a rigid pavement, 7 meter wide. So this is the BOQ as per the original design. Okay. So you can see for 1 kilometer, the cost coming out was 2 crores 35 lakhs 92,432 rupees. This is as per the original design, the cost incurred. And as per our design, if you can see, uh, it is coming out to be 1 crores 63 lakhs 91,713. So almost a saving of 72 lakhs for 1 kilometer. Just imagine, just by reading a simple IRC publication and just by good common sense and good engineering judgment, we were able to save 72 lakh rupees for 1 kilometer. And our project involved, I think, 15 kilometers of road design. So you can do the maths yourself, isn't it? So, what I wanted to highlight through this is that as a structural engineer, our job is not only to do, it is just not only to produce drawings and designs, but to also involve ourselves in value saving for our client. So imagine just 10.5 crore rupees were saved in this simple project just because we looked into some basic IRC publications which are freely there to be seen, and by adopting good engineering judgment and good common sense. So always remember that as a structural engineer, we should always try to come up with optimum design which ensures great savings for our client. Actually, we we lost our consultancy fee in this. I must tell you over here that we ended up losing our consultancy fees. Why? Because our fees was linked to the total project cost. So it was a percentage of total project cost. So because the total project cost reduced because of our optimum design, even our consultancy fee got reduced. But anyhow, at least we had this satisfaction that we were able to save the nation's money. Anyway, so this is one thing that I wanted to tell you over here, uh, about this interesting project where we were able to make some contribution in the terms of money saved. So that is what I had to tell you about this project discussion this time. I hope you got some inspiration to save money for your client, isn't it? And as I told you, it's not difficult actually. You should just ask questions why. For example, if you are as I told you, many people have this habit of providing, let us say, column lateral ties 8 at 100, 8 at 125. You actually do not require these close lateral ties in your column, isn't it? Unless you are, of course, not doing the ductile design and detailing, and your that reinforcement is not a part of confinement reinforcement, you don't require such closely spaced lateral ties. But some people have this habit of providing close lateral ties, very close stirrups. So you can think of saving on these costs by providing good and better designs. So that is what we had to tell you in this section. So now we come to our third segment, where we usually meet with some young upcoming structural engineer. And this time we are inviting engineer Rahul Brijpuria. So he is a BE Civil and MTech in structures. He is currently working as an assistant engineer in designs at VV Sapre Consultants Private Limited, Indore. Currently, they are involved in design of big industrial complexes and structures. And he is a familiar face on our episodes. So you have seen him participating in all the previous episodes with his comments, questions, insights. So we would like to welcome him to our show tonight. So let me just remove this screen. Yes, hello Rahul.
हेलो सर. थैंक यू.
कैसे हैं आप? थैंक यू फॉर ज्वाइनिंग. आपने समय निकाला और ज्वाइन किया, उसके लिए थैंक यू सो मच.
यस सर।
तो मैं पूछना चाहूंगा कि आपने बीई किया और उसके बाद से अभी तक का आपका यह प्रवास कैसा रहा, उसके बारे में आप थोड़ा संक्षिप्त में हमें बताइए। बीई करने के बाद से अभी जो आप काम कर रहे हैं वहां तक की आपकी जर्नी के बारे में बताइए।
सर बीई करने के बाद से ही मैं इंदौर आया। इंदौर से मैंने आईपीएस एकेडमी जो है उससे 2019 में एमटेक कंप्लीट की स्ट्रक्चर से। और उसके बाद से मैं एक जबलपुर में एक डीपीआर कंसल्टेंट्स ईडीएमजी उनके यहाँ पे काम कर रहा था, स्ट्रक्चर्स वगैरह देख रहा था उनके, जो कि
जी
इंफ्रास्ट्रक्चर से रिलेटेड, जैसे रिटेनिंग वॉल, ड्रेन्स, ये सब काम कर रहा था। फिर उसके
जी
बाद से लॉकडाउन आया और सारी चीज़ें गड़बड़ हो गई, तो उसके बाद से मैंने फ्रीलांसिंग करना कुछ स्टार्ट की,
जी
क्योंकि स्ट्रक्चर से कनेक्टेड रहना था इसलिए। फिर उसके बाद से जैसे ही लॉकडाउन हटा और डे टू डे लाइफ में वापस चीज़ें आई, तो उसके बाद से मैं वापस इंदौर यहाँ पे
जी
आया और एक अच्छी अपॉर्चुनिटी सप्रे सर के यहाँ, वीवी सप्रे कंसल्टेंट प्राइवेट लिमिटेड के यहाँ मिली, तो मैंने उसको ज्वाइन किया।
जी।
और बस उसके बाद से बढ़िया चल रहा है।
अच्छा, अभी आप साल भर से वहीं पे काम
यस
कर
सर,
रहे हैं?
साल भर से मैं वहीं पे काम कर रहा हूँ और इंडस्ट्रियल
तो
प्रोजेक्ट्स वगैरह देख रहा
जी,
हूँ, स्टील और आरसीसी दोनों काम।
अच्छा दोनों कर रहे हैं। तो
यस सर।
यहाँ मैं मतलब थोड़ा ये जानना चाहूंगा, आप दर्शकों को भी हमारे बता पाए कि पहले आप जैसे इंफ्रास्ट्रक्चरल प्रोजेक्ट्स में थे, बिल्डिंग्स और कमर्शियल डिजाइन्स में थे, और अब आप वीवीएस कंसल्टेंट्स में काम कर रहे हैं जो कि इंडस्ट्रियल स्ट्रक्चर्स के लिए एक जानी मानी कंसल्टेंसी फर्म है।
यस
तो
सर।
क्या डिफरेंसेस आपको महसूस हुए इंडस्ट्रियल डिजाइन्स और जो हम डे टू डे डिजाइन्स करते हैं उसमें उसमें उसके बारे में आप थोड़ा अगर बता पाए।
सर इंडस्ट्रियल स्ट्रक्चर में एक तो कोई भी चीज़ मतलब ऐसे फिक्स नहीं होती, कभी भी उसमें क्लाइंट का चेंज मन हुआ, चेंज की इसकी एक तो आर्किटेक्चरल आज भी बहुत ज़्यादा हो गया है कि आर्किटेक्ट इन्वॉल्वमेंट इंडस्ट्री में खूबसूरत दिखनी चाहिए बिल्डिंग, पहले
हाँ
वो चीज़ नहीं हुआ करती थी, अब वो
हाँ
चीज़ भी आ गई है, तो वो उसका भी ध्यान रखना पड़ता है, एक फर्स्ट थिंग। और दूसरा यहाँ पे बहुत अनसर्टेनिटी होती है कि लोड कब कहाँ से कितने आ जाए, कब कैपेसिटी एक्सपांसन हो जाए, ये सब चीज़ों को लेके चलना पड़ता है फ्यूचर एक्सपांसन के हिसाब से। तो
जी
एक ये चीज़ है, और लोड बहुत मतलब बहुत सारे लेके चलने पड़ते हैं, जो कि कमर्शियल में एक लिमिटेड 3 किलो न्यूटन 4 किलो न्यूटन ही जनरली होते हैं। तो यहाँ पे एक मशीन अगर आ गई तो आपको उसके लिए बहुत सारी चीज़ें करनी पड़ेगी उसको।
जी
और
जी।
स्टील और आरसीसी दोनों के कॉम्बिनेशंस आपको यूज़ करने पड़ेंगे। हाँ, और
मतलब
इसके
एक ही
अलावा सर
बिल्डिंग
लोड
में
भी
स्टील
बहुत।
आरसीसी दोनों यूज करते हैं
हाँ,
आप लोग?
हाँ, कंपोजिट स्ट्रक्चर से हो जाते हैं सर। कहीं का पता चला कहीं फ्लोर जाके स्टील पे आ गया वो, क्योंकि उसपे कोई
हाँ
मशीन्स वगैरह ऐसी रखनी थी जो कि आरसीसी में पॉसिबल नहीं हो पा रही
जी
थी।
जी। आप कुछ और भी
इसके
कह रहे थे?
अलावा इसके अलावा सर एक ये है कि यहाँ पे बहुत माइन्यूट में वर्क करना पड़ता है, क्योंकि मशीन्स जो होती हैं वो उनके लेवल्स बहुत ज़्यादा मतलब अप डाउन्स होते हैं, तो आपको एमएम में एक्यूरेसी रखनी पड़ती है। और अगेन जो आप अभी वैल्यू इंजीनियरिंग की बात कर रहे थे, उसका भी
जी
बहुत ज़्यादा ध्यान रखना पड़ता है। ऐसा नहीं है कि जो आपने 8 का 100 से ऐसे
हाँ
सरिये डाल दिए और सेव कर दिया स्ट्रक्चर, फिर वो ये भी होता है कि क्लाइंट ये भी देखता है कि मतलब कि इतना सारा कैसे ये कैसे हो गया है, उसका कॉस्ट बजट बिगड़ जाता है, ये
जी।
सब चीज़ें भी है।
तो मतलब मैं ये पूछना चाह रहा था ताकि हमारे दर्शकों को भी ये बात समझ में आए कि इनपुट्स आपके क्या होते हैं। जैसे कमर्शियल बिल्डिंग्स के लिए तो हमारे आर्किटेक्चरल ड्राइंग्स हमारे पास आती है, तो आप लोगों के प्रोजेक्ट्स में इनपुट क्या मिलते हैं आप लोगों को डिजाइन शुरू
सर
करने के लिए?
इनपुट्स में अगर देखा जाए तो मेनली जो मशीन्स हैं या फिर मतलब फैक्ट्री जो भी इंडस्ट्रियल प्रोजेक्ट जो भी बन रहा है, उसमें जो भी उसकी रिक्वायरमेंट है, तो उसके हिसाब से असाइनमेंट ड्राइंग आपकी सप्लायर प्रोवाइड करेगा। उस सप्लायर के हिसाब से आपको पहले जीए और ये सब चीज़ डेवलप करने के बाद आपको एक उससे परमिशन लेनी पड़ती है कि एवरीथिंग इज ओके, फिर उसके बाद स्ट्रक्चरल डिज़ाइन वगैरह शुरू होती है।
जी
तो फिर ये सब चीज़ें आपको ध्यान में रखनी पड़ती है। और उसके अलावा सर कोड्स वगैरह भी बहुत सारे यूज़ करने पड़ते हैं, जैसे आप 1893 पार्ट 4 1 to 4 सारे। और इसके अलावा सर मतलब और भी सारी बहुत सारी चीजें, मतलब इंसर्ट प्लेट्स, फ्यूचर एक्सपांशन, इंसर्ट प्लेट्स का बहुत ध्यान रखना पड़ता है कि कभी इन फ्यूचर
हाँ
इसने कुछ स्टील का शेड्स वगैरह बना दिए, या कुछ
जी
जॉइंट करना पड़ा, या कुछ भी ऐसा कुछ हुआ, तो आपको इन सब ड्राइंग, मतलब डिजाइन से ज्यादा डेवलपमेंट, ड्राइंग डेवलपमेंट में ज्यादा फोकस करना पड़ता है, क्योंकि एक्यूरेसी वही, और फील्ड में
हाँ
जाके वही चीज जानी है
करेक्ट।
अल्टीमेटली आखिरी में।
इसमें मैं एक और पॉइंट ऐड करना चाहूँगा कि क्योंकि इंडस्ट्रियल जो कॉम्प्लेक्सेस बनते हैं, तो इंडस्ट्रियल कॉम्प्लेक्सेस में कई सारी बिल्डिंग्स एक दूसरे से जुड़ी हुई का
यस सर।
सेंस कि एक अगर प्रोसेस है तो बिल्डिंग ए से बिल्डिंग बी, बिल्डिंग बी से
जी।
बिल्डिंग सी, सी टू डी, ऐसा प्रोसेस पूरा लिंक्ड अप रहता है। तो
यस
जैसे
सर।
राहुल एक्यूरेसी के बारे में बात कर रहे हैं, तो सारी बिल्डिंग्स शुड बी very accurately laid out on the site and their levels should be perfectly matching with each other, क्योंकि जब इक्विपमेंट उस पे लगाए जाएंगे तो इक्विपमेंट्स का सिंक में होना बहुत ज़रूरी है एक दूसरे के साथ, अदरवाइज यू गेट लॉट ऑफ इश्यूज लेटर ऑन। तो उसके बारे में बताइए कि आप जैसे आप मान लीजिए इंडस्ट्रियल कॉम्प्लेक्स में मल्टीपल बिल्डिंग्स जब डेवलप कर रहे हैं, तो साइट लेआउट के हिसाब से क्या क्या सावधानियां आप रखते हैं, मतलब व्हेन यू
सर
आर।
पहले तो बहुत सारा डिस्कशन तो पहले तो एफएफएल पे ही होता है, क्योंकि बहुत सारी
हाँ
चीजें उस पे ही डिपेंड करती हैं कि कहाँ पे, और हर चीज एक दूसरे से लिंक्ड है, तो आपको एक ना एक बिल्डिंग का रेफरेंस लेके
एक
चलना
मिनट,
पड़ता है कि।
एफएफएल एक मिनट, एफएफएल मींस फिनिश फ्लोर लेवल, सो द लेवल
यस सर।
दैट यू वांट टू गेट, वी कॉल इट एज द एफएफएल। जी बोलिए।
सर एक दूसरे से जैसे आपने बताया लिंक रहती है, तो एक दूसरे को आपको सोच के चलना पड़ता है, ये बिल्डिंग का अगर रेफरेंस ये है तो इसके आगे ये चीज आने वाली है, तो आपके लिए वो फर्स्ट बिल्डिंग रेफरेंस हो जाती है। उसका
जी
0-0 लेवल वो हो जाता है, या फिर एग्जिस्टिंग कोई स्ट्रक्चर पहले से बना हुआ है आपके लिए, वो एक रेफरेंस पॉइंट हो जाएगा। तो सारी चीजें आपको लेआउट वगैरह जो देखनी है, जो सारे लेवल्स देखने हैं नेक्स्ट अगली बिल्डिंग्स के या फ्यूचर एक्सपांशन में, तो आपके लिए वो पॉइंट एक क्रिटिकल पॉइंट हो जाएगा, आपको सारी चीजें उसके रिस्पेक्ट में चेक करनी है। और बहुत सारी चीज, जैसे सर मैंने पिछले उसमें भी पूछा था कि फाउल वगैरह बहुत सारी चीजें होती है, तो आपको पुरानी ड्राइंग्स, और अगर किसी ने और कंसल्टेंट अगर उसमें इन्वॉल्व रहा है, तो वो सारी चीजें भी देखनी पड़ती है कि वहां पे पता चला आप खोदने गए और एक पुटिंग आपके सामने वहां
हाँ
पे
आ
आ गई
गई।
अचानक से।
जी जी
तो ये सब
जी
चीजों का बहुत ध्यान रखना पड़ता है।
करेक्ट। इससे पहले कि मैं आपसे कुछ और प्रश्न पूछूं, इफ द ऑडियंस दे वांट टू आस्क एनीथिंग टू राहुल, दे कैन जस्ट टाइप इन देयर क्वेश्चंस इन द कमेंट सेक्शन। तो मैं ये और पूछना चाह रहा था आपसे कि आपकी डिजाइन प्रोसेस कुछ वेरी करती है, डिजाइन प्रोसेस इज यूजुअल दैट वी डू इन आवर जनरल बिल्डिंग्स की, कुछ अलग डिजाइन प्रोसेस आप फॉलो करते हैं इंडस्ट्रियल स्ट्रक्चर्स में?
सर डिजाइन प्रोसेस तो सेम ही रहेगी एक टाइप से, लेकिन बहुत सारी चीजें अगेन वही कि बहुत सारी चीजें देखनी पड़ती हैं, छोटी छोटी चीजें जो कि अपन इसमें कमर्शियल बिल्डिंग में छोड़ देते हैं। कई चीजें वो अगेन वो वाली एक्यूरेसी,
हाँ
वो सबसे बड़ी चीज वो करती है कि आप इसको
करेक्ट।
ऐसा नहीं कर सकते, आपने बीम को इतना निकाल दिया चल गया ठीक है ओके,
हाँ
बाद में देखेंगे।
and in many industrial structures they are extremely deflection sensitive, so for
यस सर।
example as Rahul is saying, जैसा आप कभी क्रेन करते हैं या गैंट्री डिजाइन कर रहे
हाँ
हैं, तो गैंट्रीज आर वेरी वेरी डिफ्लेक्शन सेंसिटिव, तो उसके आप डिफ्लेक्शन क्राइटेरियाज भी देखेंगे तो वो काफ़ी ज़्यादा स्ट्रिंजेंट रहते हैं। तो कई बार हमारा सर्विसेबिलिटी डिज़ाइन इज मोर क्रिटिकल देन योर कोलैप्स डिज़ाइन इन मेनी ऑफ इंडस्ट्रियल structures, I would say mostly in horizontal elements which are prone to deflections। तो किसी ऐसे प्रोजेक्ट के बारे में बताइए जो आपने अभी पिछले साल भर में किया हो, जो आपको काफ़ी चैलेंजिंग लगा और उसको आपने ओवरकम किया, उसके बारे में कुछ बताइए हमें।
सर एक पैकेजिंग इंडस्ट्री से रिलेटेड है, वहाँ पे एक्चुअली में क्या हुआ कि पहले हमने एक इलेक्ट्रिकल पैनल रूम है, उसमें सारी चीज़ें फुटिंग्स प्रोवाइड की, नॉमिनल जो अपनी जनरल होती है फुटिंग्स प्रोवाइड करी। फिर बारिश आ गई, बारिश के कारण से वो चीज़, मतलब कुछ कारण से वो खोद नहीं पा रहे थे, या फिर वहाँ पे एग्जिस्टिंग कुछ निकल आया जैसे कि मैंने आपको बताया।
हाँ
तो उसके कारण से फिर वहाँ पे पाइल प्रपोज की गई। पाइल प्रपोज करने से उनकी फिर कॉस्टिंग पे इफेक्ट आ गया कि कॉस्ट बढ़ गई बहुत
हाँ
ज़्यादा, नहीं कर पाएंगे ऐसा वैसा, तो और कुछ भी चीज़ें बहुत सारी हुई। तो फिर हमने उसको एक ड्राइंग को कम से कम 6 बार ऑल्टर करके, 6 बार रिवीजन करके, 7वीं बार में उसको फुटिंग और पाइल दोनों के कॉम्बिनेशन पहुंचाया। मतलब 12 कॉलम थे उसमें, लेकिन 12 कॉलम में 6 फाइल और 6
छह
फुटेज।
रिविजन्स 6 रिविजन्स करने पड़े आपको।
यस सर।
6 फाइल
तो
और 6
कॉस्ट
फुटेज।
कॉस्ट सेविंग्स और ये सब चीजें मतलब बहुत अल्टीमेटली, और सर अपलिफ्ट एक बहुत बड़ा, क्योंकि स्टील स्ट्रक्चर है तो अपलिफ्ट भी यहाँ पे बहुत गवर्निंग फैक्टर होता है, जैसा अपन ने पिछले वीडियो में डिस्कस किया था, एंकरेज और
जी
ये सब चीजें भी बहुत, रीवायरिंग वगैरह भी करनी पड़ती है। ये सब
जी
भी अल्टीमेटली आपको स्ट्रक्चर्स डिजाइन के अलावा बाकी सारे सॉल्यूशंस भी बहुत सारे सोचने पड़ते हैं।
करेक्ट। तो इसके अलावा जैसा आपने बोला आर्किटेक्चरल इन्वॉल्वमेंट भी आजकल बढ़ गया है इंडस्ट्रियल डिजाइन्स में, तो
यस
उसके
सर।
बारे में आप थोड़ा बताइए कि कैसे आपको ये चीज़ फील हुई मतलब।
सर जैसे कि मैं पुराने स्ट्रक्चर्स रिव्यू करता हूँ सीखने के पर्पज
हाँ,
से ऑफिस में, तो उसमें देखता हूँ कि कन्वेंशनल ट्रस वगैरह बहुत ज़्यादा यूज़ किए हैं, लेकिन आजकल डिमांड आती है कि नहीं नहीं हमको तो पीवी चाहिए,
अच्छा
हमको
हाँ,
अच्छा। हाँ, और सीटिंग वगैरह की पहले इतने ऑप्शंस नहीं थे, आजकल सीटिंग्स में और बाकी चीज़ों में भी बहुत सारे ऑप्शंस अवेलेबल है, तो क्लाइंट नई नई चीज़ें आर्किटेक्ट्स लेके आता है और फिर वो उसके बारे में हमको भी रिसर्च करनी पड़ती है कि क्या है नई चीज़ ये सब, और फिर
करेक्ट।
अल्टीमेटली कॉस्ट के बारे में भी सोचना पड़ता है कि कॉस्ट भी कितनी बढ़ रही है, ये चीज़ हो
जी
रही है। हाँ।
जी, वेरी
सर जैसे
इंटरेस्टिंग।
आपने बताया अभी इसके पहले कि वो वैल्यू इंजीनियरिंग आप कई बार अपनी फीस ही कम कर लेते हैं, तो वो भी
हाँ
होता है कि आपको करना पड़ता है वो चीज़।
हाँ हाँ, करेक्ट। तो आप हमारे ऑडियंस से कुछ अगर कहना चाहें, क्योंकि आप तो जानते ही हैं हमारी सारी ऑडियंस जनरली यंग इंजीनियर्स रहते हैं
यस
इस
सर।
ऑडियंस में। तो अगर इनको इंडस्ट्रियल स्ट्रक्चर्स में परस्यू करना हो तो आप उसके बारे में अगर कुछ कहना चाहें हमारी ऑडियंस से।
इसके लिए सर एक अलग से कुछ नहीं चाहिए, स्टील और आरसीसी दोनों का बेसिक्स नॉलेज होना चाहिए पहली बात तो, और इसके अलावा कोडल जो मतलब कोड बहुत सारे लगते हैं स्टील में और आरसीसी में, और इसके अलावा ड्राइंग डेवलपमेंट और इससे रिलेटेड बहुत छोटी छोटी सी चीज़ें, जैसे रीबारिंग का हो गया, जैकेटिंग का हो गया, इन सारी चीज़ों के बहुत सारे कोड बहुत सारे यूज होते हैं। एक जनरल अगर कमर्शियल प्रोजेक्ट्स की बात करें तो आप केवल आरसीसी 456 और डिटेलिंग, डक्टाइल डिटेलिंग या 2-3 कोड से काम कर लेते हैं, लेकिन यहाँ आपको हर चीज़ छोटी-छोटी चीज़ों से रिलेटेड बहुत सारे नोट्स लिखने पड़ते हैं, बहुत सारी वाटर प्रूफिंग से लेके हर चीज़ के एजेंट्स, ये सब चीज़ें भी प्रपोज करनी पड़ती है। ये
हाँ,
सब चीज़ें आपको बहुत सारी चीज़ें ध्यान में रख के काम करना होता है, तो ये मेरा है कि इन सब चीज़ों के बारे में भी थोड़ा-सा एक्सप्लोर करना चाहिए कि कैसे क्या-क्या होता है, और कंस्ट्रक्शन मैनेजमेंट और टेक्नोलॉजी का भी इसमें बहुत अहम योगदान होता है स्ट्रक्चर के साथ-साथ।
कैसे इसके बारे में थोड़ा बताइए ये आखिरी पॉइंट के बारे में।
सर जैसे कि अब कहीं पे एसबीसी नहीं मिल रही है, अगर और आपको कोई चीज़ फुटिंग प्रपोज़ करनी है तो आप क्या करेंगे? सॉइल स्टेबलाइजेशन कैसे करेंगे? कॉस्ट और फिर अल्टीमेटली कॉस्ट भी आपको नहीं बढ़ानी है, तो आप कैसे आस-पास के मटेरियल्स को यूज़ करके कैसे आप उसको कर पा रहे हैं? और
जी
जैसे रबर सोलिंग, ये सब चीज़ों के बारे में भी सोचना पड़ता है। आप कैसे उसको सब बेस को कैसे बना रहे हैं, और एसबीसी कैसे आप इम्प्रूव कर पा रहे हैं, कई बार नहीं मिल पा रही होती है आपको, तो ये सब चीज़ें
जी।
इसलिए ये भी मायने रखती हैं।
तो जैसा राहुल ने एक इम्पोर्टेंट बात जो बोली कि डिज़ाइन इज़ अ आई वुड नॉट से वेरी स्मॉल पार्ट बट नॉट दैट इम्पोर्टेंट पार्ट इन अ कंप्लीट I would say journey of a project. So design is a small portion of it. Other things are also quite important when it comes to big complexes, big commercial complexes, big industrial complexes. So design only has a 10-15% importance. तो बाकी चीज़ों पे भी ध्यान देना, जैसा राहुल बोले वो काफ़ी एक इम्पॉर्टेंट बात बोले। कंस्ट्रक्शन मैनेजमेंट इज ऑल्सो इक्वली इम्पॉर्टेंट। सुपरविजन इज एक्सट्रीमली इम्पॉर्टेंट व्हेन इट कम्स टू बिग स्ट्रक्चर्स। तो आई एम श्योर आप साइट पे भी आपकी खुद की सुपरविजन टीम बैठती होगी जो आपके ड्राइंग्स को
यस सर।
कोऑर्डिनेट
यस सर।
करवाती होगी साइट पे।
यस सर।
तो
क्वालिटी
दैट
कंसर्न,
अगेन।
कितनी भी अच्छी ड्राइंग या डिज़ाइन कितनी भी अच्छी हो जाए, अल्टीमेटली अगर वो साइट पे एग्ज़ीक्यूट इतने अच्छे से नहीं हो पा रही, तो इन सब चीज़ों का कोई मतलब नहीं है।
जी जी, तो
हाँ।
वो भी काफ़ी इम्पोर्टेंट हो जाता है। वेरी
यस
गुड,
सर।
नाइस। सो हमारे ऑडियंस को अगर राहुल से कुछ पूछना है तो दे कैन राइट देयर क्वेश्चंस। आपके लिए पहला क्वेश्चन है आपकी। हुसैन मोहम्मद रमीज राजा पूछ रहे हैं आपसे आपकी जर्नी, क्योंकि आपने पहले बोला कि आपने साइट पे भी वर्क किया, साइट टू स्ट्रक्चरल वर्क्स।
नो सर, डीपीआर कंसल्टेंसी में काम किया मैंने, साइट का नहीं बोला, डीपीआर
अच्छा
कंसल्टेंसी
साइट।
से
ओके
मतलब इंडस्ट्रियल स्ट्रक्चर्स में। या
इंफ्रास्ट्रक्चर प्रोजेक्ट से इंडस्ट्रियल स्ट्रक्चर्स में आप।
हाँ, यस सर।
गुड। सो अगर आपके लिए कुछ क्वेश्चंस आते हैं तो हम आपको वापस बुलाएंगे स्ट्रीम पे। तब
यस
तक
सर,
आप हमारे साथ बने रहिए और
यस सर,
थैंक यू फॉर जॉइनिंग अस। आप स्ट्रीम पे ही रहिएगा, मतलब मैं आपको यहाँ से
यस
रिमूव
सर।
कर, बट आप स्ट्रीम पे रहिएगा।
ओके
थैंक
सर।
यू। So that was Engineer Rahul. He was sharing his experiences with us tonight, and especially in industrial structures, as he said, there are a lot of other things other than design that we have to take care of. So now we move to our last segment for our episode, and that is where we have open discussion with our audience. So if you have any questions, if you want to provide any comments, now is the time to do so. So, yes, audience, I'll just remove this. And there was a question that was asked earlier. So, Sham Sundar Yadav ji is asking, would you reply on non convincing results of RCC percentage in some columns of 10-story building solution obtained from ETABS? So, according to me, I have never found out any result to be non-convincing. Uh, matlab, I found that results were quite convincing, and we were able to actually come up to the correct design to the last reinforcement square that ETABS is providing. You may have questions on analysis. You may have your doubts or reservations on the analysis, but analysis is also quite okay in ETABS. But I don't think there is any result that I have personally found as non-convincing. There are a lot of inputs and outputs that you need to be careful of. So if all those are correct, if you are providing proper inputs, I don't think any of the result I have ever found to be non-convincing. Yes, then Weber is saying, I have noticed that sometimes while merging shells in ETABS, local three direction is reversed. Yeah, I have also noticed that if you are merging, let us say, two shell elements, sometimes the local axis 3 gets reversed. That is, many a times that happens when you have made those slab elements. Originally, when you were making those slab elements, you made them in the opposite orientation. That means one slab element you made it clockwise, the other you made it counterclockwise. Then when you merge them, this type of a thing happens. So his question is that the local 3 is reversed and may affect results. So, oh, okay, it's not a question, it is an observation. So, always make sure that the orientation is correct before analysis. Yeah, very important. You should always try to observe before you apply the loads. Before you apply the loads, before you run your analysis, just try to ensure that your all these shell elements, all the line elements, the local axis is proper, correctly oriented. This is more important for the shell elements, not as much important for the frame elements. But yes, he has made a good observation over here. Anything else that we would like to discuss? Any questions? No questions. Very good. So, did I miss any question in the stream? No. So, we had actually one comment from engineer Palash. It's a big comment. It's an observation, an unfortunate observation, but I can't do much to this. I mean, I have no solution to this problem. So he's saying there is a huge pay gap for structural engineers or core engineers compared with IT or analytics fields. This is making most young engineers in the industry. He continues to be confused and deviated as most are trying to somehow get out of this field. Most of us are just trying to survive in this profession. And then he continues to say it is unrealistic to expect them to be inspired or motivated. So good. So I have no actually points to add over here. So that was his comment that he had made on our YouTube video. So yeah, this problem uh, will always be there. I don't think we can match our salaries with the IT or uh, other fields. Yes, Lima is asking, welcome to today's episode. So she is asking, I have limited exposure in buildings as a structural engineer. If I want to design road, that is infrastructural projects, how can I proceed? Yeah, there is nothing stopping you from that. So as I told you, we are also basically uh, more competent in structural designs, building designs. But when this project, which I was sharing with you in today's episode, that came to us, then we did it. I mean, see, at the end of the day, you have to read codes, isn't it? So till now we were reading IS codes, then we started reading IRC codes. So it's quite, I mean, it's quite okay to make a switch, and more than quite okay, it's quite easy to make a switch. All right, and especially when it comes to designing, because we as structural engineers have a lot of experience in designing, the design comes very easily to us, whether it is design of, let's say, pavement or crust, uh, be it rigid pavement, be it flexible pavement, or it comes to design of curves, vertical curves, horizontal curves. It is all common sense. It's not very hi-fi engineering. It's good common sense. And if you have that, generally structural engineers have that common sense, it would be easy to make a switch into this. There are some very useful actually software. So I would share over here that when we were doing this project, what we showed, we were not good at the road softwares, infrastructure softwares, especially uh, there are good softwares for calculating the quantities. Okay, so when you decide a L section and when you finalize your cross sections, then depending on the contour, very easily you are able to calculate the bill of quantities. All right, cutting, filling, all those things you can quite easily calculate using some good software. There is, I think, one software called as MX Roads. There is another software that is a product of Autodesk. I don't remember the name. So because we were not aware of those, I mean, because we did not know how to use those softwares, we had to do a lot of dirty work in calculating the quantities. But we were able to do that. So at the end of the day, it is just good common sense and good engineering practices that you have to adopt. It's quite easy, I would say, over here. See, in structural designs, sorry, in transportation design, the transportation engineer also have problems in bridge designing, culvert designing. So we are already good at that, isn't it? Retaining wall designing. So that part we can easily take up. We can do the pavement design also. That's quite simple. So I don't think it's quite difficult to make a switch. Actually, transportation engineering is more interesting than our day-to-day building or industrial projects. Then Levi is asking, what about detailing? Where can we detailing? I'm not sure what you want to ask. Detailing means drawing, VOQ. No, I'm not sure what the question is. What about detailing? So when we were doing this infrastructure project, I just referred to our old transportation book that many of us have referred, isn't it? Khanna Justo. So that is quite a good book to learn the basics of. That is quite a good book to learn the basics of transportation engineering. So I referred to that. Then we made some quick Excel sheets for iterations, and we were able to do the project quite successfully. Okay, Lima means drawing. So what about drawing? From where we can refer? So drawings, I don't know where you can refer. I'm not quite sure from where you can get the. Maybe from some other project that was done in the past. If you can get some sample drawings. Atif is saying she means detailing how it is done in infra projects like SP34 for buildings. Oh, okay. So I'm not quite aware of it. There must be some IRC for it, but I'm not quite aware. And I must say, as I told you, there is a lot of saving actually that is possible in transportation projects in roads that currently the transportation designers are not doing. So not every time you need a 300 thick uh, pavement, isn't it? So there's a lot of work that I think needs to be done in the road designs, pavement designs, especially that are being done these days. Good. Weber is asking, we design footings using separate reaction. Yeah, this is actually an important point. So Weber, who is a regular participant in these episodes, he actually was doing a work on one of his projects, uh, where he did where he modeled the raft together with the building. That means the superstructure and the raft were modeled in the same ETABS model. Okay. Uh, I mean, the usual process that we follow is that you make a building in, let's say, ETABS, then you uh, export those reactions to SAFE and do the modeling in SAFE, designing in SAFE. So you apply fixed supports in column ETABS, and then you bring it to SAFE. There you apply subgrade modulus, isn't it? So when in ETABS you are getting reactions corresponding to a fixed support, but when you bring it to SAFE, you are analyzing the footing uh, s- as a uh, as a support which has tendency to settle. So he did that experiment, and we discussed this experiment. Means he did this work where one model he made, where he modeled the footings with the building in ETABS, and then he also followed the usual process where we take the where we take the column reactions to SAFE. So he had some interesting findings. So he's writing about those findings, and he's saying that we design footings using separate reactions having fixed support. However, if we model actual footings with the superstructure in check, the column moments increase in the bottom region. So he's saying that when you actually design a complete superstructure and substructure together in your ETABS, let's say, then he found out that the column movements at the base were more as compared to when you export it to SAFE. Very interesting. I think he should present this in a better way. Perhaps we will call him in the next episode and he can share these findings in a more proper way with us. He is continuing that the movements generated in raft due to soil pressure will get transferred back to the column. So I think this is the reason for increasing movement. Yeah, I think the overall stiffness changes. So till now, when you were modeling the column as a fixed support, then the stiffness was something else. And now when you model it as a column resting on footing, then actually the stiffness has changed. So the redistribution of moments, or the redistribution of moments, will take place due to change in stiffness. That is what I understand is happening. So you can check for the overall moment in the column, as you were telling me yesterday we met at a function. So he was telling this, that the overall movement is actually shifting from the top of the column to bottom, isn't it? That was your observation, I think. So as I understand, it is mainly due to a change in the stiffness of your column at the base. Yes, quite interesting. I think this actually warrants more time. This discussion is important. If you see IS 456, or even if you see IS 800, they don't actually tell you to model a fixed support. They actually tell you to model supports for your structures on the basis of their stiffness. So if you read the IS 800, there is a clause that tells you that to model the support for your steel column, you have to do it on the basis of stiffness. So sometimes you may have to apply spring-like supports, which simulates the settlement of your substructure. Quite interesting, right? Anything else? Right. So I think we had a good discussion today. So the takeaway can be that in uh, as a structural engineer, we should always try to do some value engineering in our projects. It is our duty to bring out the cost saving for our clients. So that was one takeaway. And another takeaway was that in industrial structures, when you are designing, you have to look at a lot of things which are other than design. You have to take a complete picture of your project. So that is all that we had. Thank you. And थैंक यू राहुल, आपने समय निकाला और हमको ज्वाइन किया आज के एपिसोड के लिए. थैंक यू सो मच.
थैंक यू सर। और आपसे और आकांक्षा मैम से बहुत हर समय हेल्प मिलती है और उससे इंस्पायर होके आज यहाँ पे हूँ।
थैंक यू. ऐसा ही आप अच्छे करते रहे. तो इसी के साथ दैट इज ऑल दैट वी हैव फॉर दिस एपिसोड. Next time when we meet, it would be after Dashera, I think. So have a good Navratri, uh, and we will see you after Dashera in the first week of October. So till then, have a good weekend. Take care, and next time we will see you in the first week October. Bye bye. Thank you. Have a good weekend.